Crew-12, restoring operational capacity to the International Space Station opening sequence low Earth orbit, approximately 400 kilometers above Earth's surface, traveling at 7.66 kilometers per second. The International Space Station circles the planet once every 90 minutes. It is the most complex structure ever assembled in space, a permanently crewed microgravity laboratory sustained by international cooperation. A medical emergency that required the premature departure of a 4-member crew. A replacement mission, SpaceX Crew-12, would launch to restore full scientific capacity aboard the station. This is the story of how Crew-12 reestablished a 7-member expedition and resumed. Part 1. The medical evacuation human spaceflight is engineered with redundancy in propulsion, in life support, in communications. But the most critical variable remains the human body. Under established safety protocols, when a Crew Dragon spacecraft undocks, the consequence was immediate. The station's population dropped from 7 to 3. Part 2. Why crew size matters. The ISS is not merely inhabited, it is actively operated. A full 7-member crew allows parallel execution of scientific experiments, continuous maintenance of environmental control systems, robotics operations, preparation for visiting cargo vehicles, priority shifts toward life support maintenance and critical station systems. To restore research throughput and operational resilience, NASA and SpaceX advanced the launch schedule of Crew-12, Part 3 launch and orbital insertion on February 13, 2026. A Falcon 9 rocket lifted off from Cape Canaveral, carrying the Crew Dragon spacecraft into low Earth orbit. The mission profile followed a standard commercial crew trajectory. 1. Once docked, the real work for Crew-12 began. The International Space Station isn't just a home in orbit. It's a world-class laboratory, a stepping stone to the cosmos, and for the next 6 months, it was their office. The cruise days were meticulously planned, often scheduled down to 5-minute increments. A major focus of their mission was human biology. How does the body adapt to long-duration spaceflight? On board, astronauts conducted experiments on themselves, studying bone density loss, muscle atrophy, and the curious fluid shifts that occur in microgravity. They use advanced ultrasound equipment to monitor their cardiovascular systems and collected samples to analyze changes at the genetic level. This research is not just for future astronauts on missions to Mars. It has direct applications back on Earth, helping scientists understand aging and diseases like osteoporosis. But their work extended beyond their own bodies. In the European Space Agency's Columbus module, they cultivated protein crystals, which grow larger and more perfectly in space than they can on Earth. These crystals help research design more effective drugs to combat a range of illnesses. In the Japanese Kibo lab, they operate the station's robotic arm, deploying small satellites built by universities around the world, fostering the next generation of engineers and scientists. They also tended to a space garden, testing new methods for growing fresh food, a critical technology for sustaining crews on long journeys away from our home planet. Life aboard the ISS also involves immense operational responsibility. The astronauts are the ultimate handymen and women, tasked with maintaining a complex machine, hurtling through space at 17,500 miles per hour. They perform spacewalks, known as extravehicular activities, or EVAs, to upgrade the station's power systems. Dressed in their bulky white suits, a personal spacecraft in their own right, they worked for hours in the vacuum of space, with the Earth as a stunning, silent backdrop. These moments, while breathtaking, are among the most dangerous parts of any mission, requiring absolute precision and teamwork. The significance of Crew-12 and every mission like it extends far beyond the data they collect. It is a testament to international cooperation. On board the station, astronauts from different countries, cultures, and backgrounds live and work together, united by a common goal of exploration. In an era of global challenges, the space station stands as a powerful symbol of what humanity can achieve when we collaborate peacefully. It's a beacon of hope, reminding us that we are all crewmates on this spaceship Earth. Each experiment conducted, each system repaired, builds a foundation for humanity's next giant leap. The knowledge gained from Crew-12's mission directly informs the design of the rockets, habitats, and life support systems for the Artemis program, which will return humans to the moon and eventually send them to Mars. They tested next-generation water recycling systems and radiation-shielding materials, technologies essential for keeping future explorers safe on journeys that will last not months, but years. As their 6-month tour of duty neared its end, the crew began preparing for their return, passing the torch of discovery. Deliberate separation from the orbital outpost that had been their home. The fiery re-entry through Earth's atmosphere is a final dramatic test of skill and technology. The capsule, protected by its heat shield, glowed like a meteor as it streaked across the sky. After deploying its parachutes, it splashed down gently in the ocean, bringing the crew and their precious cargo safely back to Earth. The journey of Crew-12 was more than a 6-month mission. It was a continuation of a story that began decades ago. It was a story of human curiosity, ingenuity, and the relentless desire to push boundaries. From the high-tech labs to the perilous spacewalks, their work in orbit has brought us closer to understanding our place in the universe and has paved the way for the explorers who will follow in their footsteps, venturing further into the solar system, carrying the hopes of all humanity with them. Thank you for watching. If you were inspired by this journey, be sure to follow our channel for more stories from the final frontier. For decades, humanity has reached for the stars, and missions like Crew-12 are the next giant leap in that grand endeavor. But this journey isn't just about reaching a destination. It's about what we discover along the way, both out there in the cosmos and right here on our home planet. From their unique vantage point, the Crew-12 astronauts will turn their cameras back towards Earth, conducting vital Earth observation studies. They'll track changes in our climate, monitor deforestation, and observe the health of our oceans with a clarity impossible from the ground. This data is crucial, helping scientists understand our planet's complex systems and develop strategies to protect it for future generations. It's a powerful reminder that space exploration is also about preserving our home. The International Space Station is more than just an outpost. It's a world-class laboratory floating in orbit. Here, Crew-12 will conduct groundbreaking material science experiments that are only possible in microgravity. For instance, studying how flames behave without buoyancy could lead to more efficient combustion engines on Earth and better fire safety protocols for future spacecraft. They'll also be testing advanced 3D printing techniques, using specialized polymers and even metals to manufacture tools and spare parts on demand. Imagine a future where astronauts on a long-duration mission to Mars can simply print a replacement part instead of waiting months for a resupply mission. This is the technology that will make deep space exploration a sustainable reality. But life in space is not all science and experiments. The human element is perhaps the most critical part of any mission. For the Crew-12 astronauts, the ISS will be their home for months. They'll navigate the daily challenges of living and working in a confined environment, thousands of miles from everyone they love. Psychologists on the ground will closely monitor their well-being, studying the effects of long-term isolation and confinement. These studies are essential for planning future missions to the Moon and Mars, where crews will be even more isolated. The astronauts will share meals, exercise to combat muscle and bone loss, and find moments to simply gaze out the cupola window at the breathtaking view of Earth below. These moments of quiet reflection, of seeing our world as a fragile, interconnected whole, often have the most profound impact. They return not just as scientists and engineers, but as true ambassadors of a united planet. The legacy of Crew-12 will be written in scientific papers and technological breakthroughs, but it will also be found in the inspiration they provide to millions back on Earth, a testament to human curiosity, resilience, and our endless desire to explore the unknown. Thanks for watching, and be sure to follow along as we continue to cover this incredible journey.